Hey there, boys and girls in calculus land. So, sorry to do the instruction this way. This is my only option because I can't be in class today. So, there's kind of like three aspects to u-substitution, three kind of avenues you can go on. So you learned one yesterday. It's just straight up u-substitution. I have a worksheet in the classroom that will give you some practice at that. So great. And then I want to do two videos for you. The first one is when you've got u-substitution, but it's to within a coefficient, and you'll see what I mean, okay? So I'm just going to do an example here, and then hopefully that is enough to help you do the ones on the worksheet that are within a coefficient. You know, they're not a perfect match to the original integral. Okay, so check this out. This actually is the really tough integral that I'm not sure where to look on the, is it over here? I think that's it, okay. This is the really tough integral that I had on the board the last couple of days. So now actually though you have some skills, can you tell, just looking at this, if you were forced to figure out what a u would be, can you tell what it might be? Why, yes, class, that's right. The thing in the denominator has its derivative elsewhere in the integral. So that's your u. It's not perfect, but it will be good enough that we can use this u-substitution hack, okay? So watch, I'm just going to do it and you'll see. So I'm going to say u equals x cubed plus 3x squared plus 9, okay? Got that? And then I'm going to take the derivative and solve for du. So when I do that, I get 3x squared plus 6x. The 9 disappears when I take the derivative. And now I'm doing two steps in one. I hope that's okay. I'm going to multiply by dx here. So I solve for du. And then I'm just going to notice something. And that is, well, yeah, I'm going to notice it right now rather than later. Because here's the thing. I know I'm going to have to rewrite this integral. And so I can tell that on the bottom, instead of this blob to the fourth, I'll just have u to the fourth. This part right here, this x squared plus 2x dx, I don't have that down here. Except, do some of you see what I could multiply both sides of this guy by so that that appears? Why, yes, class, that's right. You could multiply both sides by 1/3, and watch what happens. If you don't see it, watch this. So I'll have 1/3 du, and then multiply this guy by 1/3, bam, x squared. Multiply this guy by 1/3, bam, 2x, and it's still dx, okay? So let me get my red Sharpie here. So now I'm going to start rewriting the integral, this tough integral, and I'm going to make it into an easier integral, okay? So I've got an integral sign, bam. So I'll make my integral sign, bam. I've got, oops, well, here. I've got this thing right here that I have to express. And so that is just going to be u to the fourth, right? Because it's a blob to the fourth, and that's u. So it's just u to the fourth, okay? And then what's the only thing that I haven't expressed so far down here in this new integral? It is this thing right here. But guess what I'm going to call that? Can you tell that that is just 1/3 du? Okay? And I can clean that up a little bit so that it looks like something you're used to. First of all, can you always kick out a coefficient? Yes, of course you can. So I'm going to kick out that 1/3. So I'll just put it out front here. 1/3. Bam. And then probably this will bother some of you if the du's up there. Eventually that won't bother you and you'll just be like, okay, whatever, I can do this integral now. But let's say it bothers you. So do you agree that I can always do this and just put it out front there? You see that those last two lines are equivalent to each other? Well, in this case, now it's all over but the shouting. I'm just going to do my integration. Can you tell, by the way, look how happy we are. Very difficult integral, much easier integral, right? That's what's so powerful about u-substitution. So I'm just going to write 1/3 u to the -4 du. And then when I do my integration, I take the antiderivative. I'll get 1/3, let's see, negative u to the -3. Oh, I'm sorry, with a 1/3 up front. Oh, that's it then, right? Plus, I guess I don't have to worry about mistakes, right? This isn't on a whiteboard. So plus c. Let me just make sure I got that right. Yeah, I did. Okay, so you guys got that? And then, look, can we always, running out of room here. You can still see. Okay, so can I make this be -1/9 u to the -3 plus c? Right, I just multiplied the two fractions together. And then, my last step here, if you guys remember the notes that you took yesterday, the last step, if you have an indefinite integral, which we do, there are no limits on this. If you have an indefinite integral, you just put everything back into terms of x. So I'm done. So I'm going to put everything back in terms of x. So instead of a u, I'm going to put down what we have u originally equaling way up there. X cubed plus 3x squared plus 9 to the -3 plus c. Shazam, kabam. Would you have ever guessed that that was the answer when we first looked at this guy? I mean, probably not. So that's what's so good about u-substitution. Before I close out the video, then I just want to say the main new learning here is that if you get something that's not a, where are we? I'm sorry. If you get something, a du, that's not a perfect match, but it's only off by a coefficient, you now know how to handle that. You just manipulate that by multiplying by something so that you do get a perfect match. And then that whatever your constant that you had to multiply by, that just ends up in your integral and you just, can kick it out or whatever. Okay?